Welcome back. So far, we learned how to run our application using deployment and scale them to meet demand. But there is a critical best practice we need to discuss. How do we manage application configuration? How do you tell your application which database to connect to, or provide it with API key for external services? The worst way to do this is hardcode these values directly into your container image. This makes your image inflexible, difficult to manage across different environments like dev, staging, and production, and it's a huge security risk. The proper way to decouple your configuration from your container image. Kubernetes provides two core resources designed for this exactly purpose: ConfigMap and Secrets. Uh, think of them as official Kubernetes way to store, manage configuration data. A config map is used for non-sensitive plain text information. This is perfect for things like URL, feature flags, or general application setting. A secret it's designed for sensitive data like password, API token, or TLS certificate. Both of these resources store data as key value pair, and importantly, they can both be injected into your pod in two primary ways, either as environment variable or mounted file in a volume. Let's start by dividing into the config map. Let me switch to the terminal. Okay. We can create config map directly from our command line. The simplest way is form of literal key value pair. Let's create a config map to hold some database configuration. This is the command. So the command is kubectl create config map. The name is dbconfig, and we are using from literal, which means from command line, and then we set the key, which is dbhost, and then the value, which is MySQL service, and the same again with db user, and the value is backend. Let me press enter. So by this imperative way, I'll create this config map. In our case of need to have it as a YAML format, you can generate the YAML output using the two flags, dry run client and -o YAML, which means that this output in a YAML format and the change is nothing going to apply or create in the cluster and just for validating. Let me show you. So imagine that we run the same command again, but now we are using these two feature flag in kubectl. Dry run client, which means that this is only running in my client and it's not going to apply on the cluster, and -o YAML, which means that the output is in YAML. So as you can see, it created a config map in YAML format for us, and it's not created on the server. This is really helpful when we want to create multiple YAML file, or we want to keep the version YAML file in version control. Instead of using imperative way, we want to use declarative YAML configuration. So if you look at the YAML in this config map, it's very straightforward. All of our key value pairs are stored on the top level data field. As you can see here, it's a MySQL service and DB is backend. Now that we have our config map, how do our pod actually use it? The first and the most common way is to inject the entire content of a config map into a pod as environment variable. We do this in our pod manifest using n-from, a config map reference. Let's demonstrate it with Ubuntu pod attaching a dbconfig as environment variable. So let me create a YAML file for Ubuntu pod, and let's review this together. So in a spec part, which we have container, in the container field we have n-from, and we are using this config map ref and using dbconfig as a value for this key. So if we save this YAML definition and apply this, to YAML, you can see that a pod is creating, and we'll wait until the pod is ready to use. Let's wait a bit. So now it's in running state. Now we can execute, and if we run this command, we will see the config map successfully inject environment variable. I'm using print in env as a command line, and I'm grabbing to the db underscore, which we can see that the db host and db user already injected into the pod as environment variable. Or you can exec into the pod with bash. Right now I'm in the pod, and I can use the print and then see the all environment variable here, and you can see that db host is here, which is MySQL service. This is pretty straightforward. When we create a pod with this definition, Kubernetes will take every key from the db config in config map and create an environment variable with that name inside of the container. So I think this is pretty obvious. The second powerful method is mount config map as a volume. This is perfect when your application expects configuration in a file like a JSON or a YAML or properties file. First, let's create a config map, this time from a local file named db.json. This is pretty common for Java application. Let me create a database file, db.json, like db host, or this is maybe used for Node.js application, reading data configuration from the JSON file. And the second command I'm going to run is creating the config map, this time based on from file. This will create a YAML for me. Let's use the same dry run command and output in YAML, so we can see what will be the end result. So as you can see, it create a config map for us. This time the key is db.json, and then the value is the content of the file. So yeah, it is. So let's create this config map again without the dry run, so this will apply on the server. So if we get the config maps, we can see that we have two config map, dbconfig and dbconfig file. This dbconfig file is the configuration that we want to use now as a volume in our pod. Now in our pod spec, we define a volume that reference our config map, and then a volume mount inside of our container to place that volume into the specific path like etc db and db.json. So let's create another definition. This time let's name it Ubuntu cm mount.yaml, and here as name we can also name it Ubuntu cm mount, which means config map mount. So here we have two important configuration. First one, which we point to the volume config map, and the name is dbconfig file which we created. And the most important thing here, we use the key, the item key, and the path is db.json. And then here in the volume mount, we use etc db and db.json as a mount path, and the subpath is db.json, of course. The reason we have volume and volume mount, which it is that we can reuse the same volume in multiple container in the same pod. So imagine that we have 3, 4, or 5 containers, and we want to use the same configuration in all of them. We don't need to basically create a volume for each one. We only need to use our volume mount, that already existing volume, into the different containers. That's the relationship between volume and volume mount. We'll talk more about the storage in storage section. But yeah, let me just save this file and apply Ubuntu CM mount. So now let's get the pod. We should soon, yeah, the pod is now running. Perfect. So now let's print the information. Let's get the shell inside the pod and see what's inside of the etc config directory. So I'm using exec again, and here for the container name, I'm using the Ubuntu CM mount, and then I'm cat, which means printing the information in etc db and db.json. As you can see, we have the file here presented. So as you can see, the config map is a very useful tool to set and keep the static configuration or even file. So it's not just a Kubernetes object for managing the configuration, and can be used as a way to mount scripts and small files into the pod. For example, let's add a script file to the Ubuntu image and then change the entry point to read the script. This way we don't need to rebuild the container again, or container image again. So we only change the enter point. Let's first start with script. So here is script. So script is pretty simple. It's a hello world script, which is while true, which means forever. It will printing the hello world on the screen every 2 seconds. So let's create the hello script. So a script created, and now let's create the pod definition, which reuse this script as the entry point. Now let's say this is hello pod.yaml. Now if you look at the definition, we are using, let's remove this, let's use Ubuntu, the same image that we use for other ones. We mounted this config map as a script volume, and we use this script volume here in this mount path, and the command line we use this script hello.sh. So instead of running just using the image without any specific command, now we are using a mounted script as a mounted script in config map as entry point. So let's apply this hello pod YAML. Okay, the pod got created, and now you can see that pod is in running state. Let's get the logs of the pod. As you can see, every 2 seconds it's printing hello world on screen. Remember, if a config map content changed, the pod is not automatically the changes and restarted in the pod. In this scenario, that the pod needs to restart or reload configuration in case of change on config map, we can use a third-party tool like a reloader. So just remember this important point, that whenever the config map changed, you need to kill or change the pod. Let's just check it together. Like we have the config map, hello script. So we can edit this hello script, and instead of hello world, we can say that hello universe. Okay, now the content is changed, the content of config map changed. But if we check the log of the hello pod again, it's still hello world. But how to restart the pod? One way to achieve that is deleting the pod. But removing the pod means that it's not gonna create again. If we were using the deployment, things were different. That's the beauty of deployment, because we can remove the pods and then the pods appearing again. So let's remove this hello pod. It will take some time because of the entry point of this pod, but eventually it will be removed after the kubectl confirm that the pod is removed, and then we can create the pod again. And this time we should see that it's printing hello universe. Okay, apply. Let's get the pods. So it's already removed. Let's apply the hello world YAML and get the pods. Now let's check logs together. As you can see here, now it's hello universe. So let's back to the slides. Now let's talk about secrets. And before we do anything else, I need to make a very important point. Kubernetes secrets are base 64 encoded. They are not encrypted by default. As we discussed before in Kubernetes architecture lesson, every information in Kubernetes is stored in etcd. And to make sure that the etcd keep data secure, we should make sure that the encryption enabled for etcd instances to keep data encrypted, not as a plain text. So just remember this part, which is first, the secret is base 64 encoded, and the second part, etcd is not secure by default, and we need to enable the encryption on the etcd. Base 64 is encoding, not encryption. Anyone who can read the secret object can easily decode it. Secrets are designed to protect you from accidentally checking a password into the Git repository, not to protect you from a sophisticated attacker who already has access to your cluster. For true security, you should use external secret manager like HashiCorp Vault, where you can rotate the secret and keys. But for now, let's learn how to use a built-in secret object. Let's back to the terminal again. Creating a generic secret is very similar to creating a config map. Let's use the kubectl command again. And here, as you can see, I used create command, and the name of object is secret, and the name and the type is generic, and the secret name is dbcret, and I'm using it from literal from the command line, and key is db password, and the password is a strong password. I can use the same dry run command and output YAML, which were used in a config map creation. And as you can see, nice. I provided the password in plain text. The kubectl command automatically base 64 encoded for us when it creates the secret. If we look at the YAML, we can see the result. So here in this string, base 64 string, isn't magic. It just base 64 encoded version of a strong password. So let's echo this string, and let's decode it. base64-d. And as you can see, here is a strong password. Consuming a secret works almost identically to consuming config map. We can inject it as environment variable using the secret ref. So same as the config map pod, which we created pod definition. We are going to create another pod named secret pod. And then here, instead of only having config map dbconfig, we also use another key, secret ref. By this way, we mount both configuration into the pod as environment variable, or we exposing this key values into the environment variable, and we can use as much as we want the secrets or config map reference. So it's dbconfig and dbcreds. So let's create the pod. This time we should see more than just config or dbconfig data in environment variable. We should also see the secrets. So let's apply secret. While okay, we can see that the container is creating. The great thing is our application doesn't need to know anything about base64. Kubernetes handles this decoding for us automatically before injecting the value into the container environment. So we can see that something is wrong. Let's describe the pod and see what has happened. Describe pod. So here it says that dbcreds does not found. It means that when I created the db credential secret file, I used the dry run command, and that way it's not stored in the Kubernetes. So let's create dbcred instead of using -o or --. So as you can see now, the secret got created. Soon we should have the pod running. And you can see this, yeah, the dbcred is here and the pod is now running. Yeah. Let's use the same command that we used for config map, grep the db underscore, and now we can see that we have three keys: db host, db user, and db password, because we mounted or we used the secrets into the environment variable YAML definition in the pod. And similarly, we can mount secret as volume, which is very common for things like SSH keys or TLS certificate. The process is same as config map, but you specify secret block in your volume definition instead of config map block. Let's see. Okay. So I name it the pod secret mount.yaml. As you can see here in the volume section, instead of config map, you're using secret name, secret and secret name. And then here in the mount path, we are mounting the secret into etcdb. What it's doing, let's apply this file. Okay. As you can see, this pod, secret mount pod, is running. Let's execute and cat the db password. So the thing is that let's hash say db, and then db underscore password is strong password, as you can see here on my command line, and it's mounted into etc/db/db password. So in this secret, I only had one key. If I had more than one key, we would have all keys here with their key and values inside of them. So let's quickly recap. To properly manage application configuration, you must decouple it from your container image. For non-sensitive data, use a config map. For sensitive data, use a secret. And always remember that it is encoded, not encrypted. Both of these powerful resources can be consumed by your application either as environment variable or as a file mounted in the volume, giving you complete flexibility to configure your workload for any environment. Thank you for watching. I'll see you in the next topic.